Good day everyone, we are the group that will going to present the Kruskal Wallis test. But first, here are our group members. Ranzi Niles Olager, Jairus Galora, Daniel Rose Liwanag, Erica Miranda, Joanna Miles Policarpio, Cheska May Cabrera, Joy Bardonado, Jo Marie Javierto, Justin Cabañas, and Ailia Kailan Yabut. So, the next slide is the table of contents. We have the overview, example, real-life application, and then the case study. And we will now start our group presentation.
Yan. So, hello guys. My name is Joanna Miles Policarpio. So, yung topic po pala ng group namin is Kruskal Wallis test. So, what is Kruskal Wallis test? The Kruskal Wallis test or H test is a hypothesis test for multiple independent sample, which is used when the assumptions for a one-factor analysis of variance are not met. So, yung meaning, marami siyang sample pero independent sila or hindi nila kailangan ng ibang characteristics para makuha na ng frequency. So, ginagamit ito sa pag-a-assume ng isang factor na hindi nakakapag-comply sa kailangan sa variance analysis. So, tinatawag din itong distribution free test dahil ito ay non-parametric test. At ang mga data na ginagamit dito ay hindi normally distributed. Ito yung pinagkaiba ng Kruskal Wallis test sa analysis of variance. So, at ang requirements lang ng Kruskal Wallis test ay ordinal scale yung mga to. Yung mga data nito. So, kapag sinabing ordinal, may mga characteristics or categories yung mga data nila. So, dito, ipapakita natin yung pinagkaiba ng analysis of variance or Kruskal Wallis test. Sa analysis variance, ipinapakita yung difference ng mean. Sa Kruskal Wallis test, ipinapakita naman yung difference ng rank. At ang Kruskal Wallis test, ordinal variables at sufficient at hindi gumagamit ng difference sa value. So, sa next slide po is ipapakita naman dito yung mga example ng Kruskal Wallis test.
How must the variables be scaled? So, a nominal or ordinal variable with more than 2 expressions. Ayan. So, based on the PowerPoint para ma-scaled, yung Kruskal Wallis test, kailangang available yung mga characteristics ng mga random samples. So, and for example, pipili ka ng newspaper kung kailan sila maglalabas ng newspaper. Example natin doon yung frequency ng paglabas ng newspaper. Example, yung daily, several times a week, or sometimes once a week. Only, rarely, or bihira at never yung never sila naglabas. So, doon yung pinaka-highest na frequency is 1. Yung daily lang. Kasi araw-araw tayo may balita. Kaya 1 yung mataas na frequency. 2 naman yung several times a week. And 3 yung rarely. And 4 yung never. Kasi pinakababa yung never. Kasi very impossible na hindi sila maglabas ng news or issue yung isang newspaper company. Yun ang sa independent variable na nominal or ordinal variables with more than 2 expressions. So, next naman natin is yung dependent variable na metric or ordinal variable. Since dependent variable siya, sa isa lang siya na hindi siya nakadepende sa iba. So, example, yung salary. Well-being at weight. So, hindi sila connected sa isa't isa. Yun yung pinagkaiba pag may more than 2 expressions sa isang expression yung binigay. Then, null hypothesis. The independent samples all have the same central tendency and therefore come from the same population. So, ano nga ba yung null hypothesis? So, a null hypothesis is a statement that suggests that that there is no relationship or walang kaugnayan sa pagitan ng dalawang minimeasure nyo na phenomena o walang kaugnayan sa pagitan ng dalawang group. So, meaning to say, ito yung isang hypothesis na nagmumungkahi na walang pagkakaiba sa pagitan ng dalawang group or conditions. Ayan. So, example, yung average na edad ng mga customers sa isang grocery store ay pareho para sa mga lalaki at babae. Okay, then yung alternative hypothesis naman. So, at least one of the independent sample does not have the same central tendency as the other samples and therefore come from a different population. So, ito naman, kabaliktaran siya ng null hypothesis. So, pinapaliwanag nito yung palagay ay may pagkakaiba, pagkakaugnay, epekto or interaction sa mga variable.
Calculate Kruskal-Wallis test. So, the calculation for the Kruskal and Wallis rank variance analysis ay similar sa Mann-Whitney U test, which is parehas silang non-parametric counterpart of the t-test para sa mga independent samples. Okay, so let's say na tama yung null hypothesis and no difference between the independent samples. Then the high and low ranks are randomly distributed sa mga samples and should be equally distributed sa mga groups. Okay, so therefore, the probability that a rank is assigned to a group is the same for all groups. So, kung walang difference between the groups, it means that the mean value of the rank should also be the same in all groups. So, this is the formula for the expected value of the ranks for each group. The expected value is equal to the sample size plus 1 over 2. So, bawat samples ay same ng expected value of the ranks, which corresponds to the expected value of the population. Furthermore, the variance of the ranks is needed. So, this is the formula to calculate for the variance. Rank variance is equal to small letter n squared. So, the small letter n is the total sample size minus 1 over 12. So, in the Kruskal-Wallis test, the test variable h is calculated. The h value corresponds to the x squared value and is given by this formula where small letter n is the total sample size, ni is the number of cases in individual group. R bar is the mean rank sum of the individual groups, and ER is the expected value of the rankings, and the sigma squared is the rank variance.
So we have written down here the measured reaction time in a table, and i-assume lang natin na yung data is not normally distributed and therefore we have to calculate using the Kruskal-Wallis test. So then, ang ating null hypothesis ay there's no difference between the groups and itetest na natin siya ngayon. Next slide po. For example, let's say we have to measure the reaction time of the three groups. So, meron tayong group A, group B, and group C. And aalamin nga natin ano nga ba ang pagkakaiba ng mga groups na ito in terms of their reaction time. Next slide po. First, we assign a rank to all groups. Depends on their response time. So, kung sino po yung may pinakamababang response time, siya yung rank 1. And sunod-sunod lang po siya. So, kung paano naman po makuha yung rank sum, ipag-a-add lang natin yung rank per group and ito total na yon. So, para makuha naman yung mean rank sum, yung total ng rank sum, i-divide siya by kung ilan yung nakapaloob per group. So, sa group A, meron tayong rank na 2, 4, 7, 9. So, ipag-a-add lang po natin siya and ayun na po yung magiging rank sum natin. Para naman po makuha yung mean rank sum, yung total ng rank sum which is 22, i-divide po natin siya sa 4 and yung sagot po is 5.5. Yun na po yung mean rank sum natin. Next slide po. Ganun din po gagawin sa group B. Ipag-a-add po natin yung rank which is 10 plus 5 plus 11 plus 1 is equals to 27. And para makuha po yung mean rank sum, 27 divided by 4 kung ilan yung group B. And yung sagot po is 6.75. Yun na po yung mean rank sum natin. Next slide po. Sa group C, ganun din po. Ipag-a-add lang po natin yung 3 plus 6 plus 8 plus 12 is equals to 29. And 29 divided by 4 is equals to 7.25. And ayun na po yung mean rank sum natin. So, next slide po. After makuha ang rank sum at mean rank sum ng buong group, dito na natin i-calculate ang expected value of the rank sum. The expected value, if there is no difference in the groups, would be that rank sum of 6.5. So, paano nakuha yung 6.5? So, yung rank po natin is total of 12 plus 1 divided by 2 is equals to 6.5. So, ayun na po yung expected value po natin to calculate the Kruskal-Wallis test.
Ngayong nakuha na natin ang ating rank sums at mean rank sums, we can go proceed to calculate the expected value of ranks. And here's the formula, which is number of cases plus 1 divided into 2. So, meron tayong 12 cases, which is itong each individual na kumuha na natin ng data. So, plus 1 divided into 2, ang equal is 6.5. Ngayon nakuha na natin itong expected value of ranks. Proceed na tayo sa next slide, which is kunin na natin yung iba pa nating kailangan para masagawa natin yung each test. Unang-una is number of cases is equal to 12, katulad nga lang sabi ko kanina. Depende sa kung ilang individual ang kinuha na natin ng data, which is 12. Sunod is degree of freedom. Ang ating degree of freedom is 2. Para naman makuha natin to, tingnan lang natin kung ilang groups meron tayo. Meron tayong 3 groups minus 1. So, makukuha natin is 2. So, next is rank variance. And ito naman yung formula sa ating rank variance. Number of cases squared minus 1 divided into 12. So, meron tayong 12 cases squared minus 1 divided into 12 is equal to 11.92. So, ang ating rank variance is 11.92. Sunod naman is expected value of rankings. Ito yung kinompute natin sa previous slide na equal 6.5. Mean rank totals. Ito naman yung mga total ng mean ranks na kinompute din sa mga previous slide. So, proceed na tayo sa H-test dahil kumpleto na natin ang mga kailangan natin. So, ito po yung formula sa ating H-test. N is for the number of cases. R bar is for the mean rank totals. Tapos, ER is for the expected value of ranks. Sigma squared is for the rank variance. So, meron tayong 12 cases, kaya 12 minus 1. Tapos, itong 4 naman, nakuha natin to kasi meron tayong 4 individuals for each group. So, for the first mean rank, 5.5 minus 6.5 na expected value of ranks natin. Tapos, sunod is the mean rank for the second group is 6.75 minus the expected value of ranks. And ang ating mean rank para sa ating third group is 7.25 minus 6.5, which is the expected value of ranks, divided into 11.92 na ating rank variance. So, equal to 0.5. So, So, ngayong nakuha na natin ang H value, pwede na tayo mag-proceed sa chi-squared distribution table. So, meron tayong degree of freedom na 2. At i-assume natin na ang nakuha nating H value is 0.5. Makukuha nating chi-square value is 5.991. After the H value or the chi-square value has been calculated, the critical chi-square value can be read from the table of critical chi-square values. Next slide. A significance level of 5%, the critical chi-square value is therefore 5.991. This critical value is therefore greater than the calculated chi-square or H value. Thus, the null hypothesis is maintained and there is no difference in reaction time in the three groups. That's all.
The real application of Kruskal-Wallis test. So, the Kruskal-Wallis test is a non-parametric statistical test na ginagamit para malaman kung meron bang significant differences between two or more independent groups. It is also a useful tool for analyzing data when the assumption of parametric tests such as ANOVA cannot be met. So, ANOVA is an analysis of variance. Isang real application of the Kruskal-Wallis test is in medical research. So, for example, gusto ng mga researcher na i-compare yung effectiveness ng tatlong magkakaibang drugs for treating a particular condition. So, the researcher could use the Kruskal-Wallis test to determine whether there are significant differences in the effectiveness of the three drugs. Okay, so another example is in business, where a company may want to compare the sales performance of its products in different regions. So the Kruskal-Wallis test could be used to determine whether there are significant differences in sales performance between the regions. So overall, the Kruskal-Wallis test is a versatile tool that can be used in any situation, whether there are multiple independent groups and the data does not meet the assumption of parametric tests.
Hi, I'm Cheska May Cabrera, and today I'm going to discuss about the research article titled Knowledge, Attitude, and Practice Toward the Coronavirus Disease or COVID-19 Outbreak Among Selected Employed People in National Capital Region in the Philippines. So, credits to Sir Angelito Bautista Jr., Diane Balibrea, and Doris G. Bleza. So, dito papakita lang natin kung paano nga na-apply yung Kruskal-Wallis para makuha nila yung kanilang conclusion or ang maging result ng kanila study. So, let's talk about first in their abstract. So, COVID-19 has challenged the pandemic response capability of many countries. Many governments around the world have imposed strict quarantine measures and border control to slow the spread of the virus. In the Philippines, the longest community quarantine has been imposed in the National Capital Region, NCR. However, the effectiveness of such measures is dependent on the cooperation of the public. The objective of this study was to gain an understanding of the knowledge, attitudes, and practices of selected employees in the NCR. An online survey was conducted June 4 until 18, 2020 with 100 employed people living in the NCR. Frequencies and percentage were computed to describe the respondents' answers, and the Kruskal-Wallis test was used to determine the differences in the respondents' KAP levels according to selected demographic characteristics. Of those surveys, 92% have a high knowledge of COVID-19. The respondents have a positive attitude toward the need for health education and the seriousness of COVID-19, as well as stricter measures against the pandemic. but are less positive in terms of how the government is responding to the pandemic. They also follow strict measures that will prevent the further spread of the virus. The results highlight the respondent favorability of stricter government measures to control the spread of COVID-19, including the reimposition of an enhanced community quarantine in the NCR. So, next is yung statistical approach. Siyempre, ang gagamitin nila dito is the Kruskal-Wallis. So, sabi dito, frequencies and percentage were computed, while Kruskal-Wallis was used to find out if there are differences between groups for gender, educational attainment, employment status, monthly income, and employment sector. The statistical significance level was set at P less than 0.05. So, yung p-value natin dito is less than 0.05. Alright, so let's go on naman sa susunod na topic. Yung table 1, pinapakita dito yung demographic characteristics. So, 100 respondents participated in the study. Of the total of 63% were women, 57% were college graduate, 85% were regular permanent employees, 28% earn more than 25,001 peso or converted into $512 monthly, and 84% were employed in the private sector. Other demographic characteristics are detailed in the table 1. So, makikita nyo naman sa table yung N and yung percent. Ayan. Parang kapag yung N niya is 63, it will be 63 din sa percent. So, times 100% lang to. 1 is to 1, 4 is to 4, 32 is 32. So, yan. And so on and so forth. For table 4, demographic characteristic of the respondent and their knowledge score on COVID-19 and result of Kruskal-Wallis test. So, the difference in the medians among different demographic characteristics were analyzed using the Kruskal-Wallis test. Makikita nyo dito sa table 4. Since the research utilized non-probability sampling, the non-parametric test was used. So, results of the Kruskal-Wallis test showed that there are significant differences in the knowledge scores in terms of the respondents' educational attainment, but not across other demographic characteristics. So, ang pinapakita dito, na meron nga siyang significant differences. Yung mga score nila, depende yan daw sa mga, dahil sa educational attainment, ganyan. Pero hindi a-across dun sa demographic characteristics. Like gender. It's not limited to gender. Pero malaking impact daw yung educational attainment. So, as you can see, meron pa tinatawag silang chi-square value, p-value. And lastly, for their conclusion, thus, the study was able to provide a benchmark of the cap of selected employed people in the NCR, Philippines, toward COVID-19. As more workers go back to work with the lifting of strict quarantine measures in the capital region of the Philippines, it is important to understand how some of them perceive the issue and in particular apply appropriate preventive measures. The respondents showed a high level of knowledge of the causes and preventive measures against COVID-19. The challenge now is to sustain this high level of knowledge, and the future researchers can validate whether this is true of the general population. Respondents also have a positive attitude toward the need for health education and the seriousness of COVID-19. Also, the respondents have become more aware of preventive practices, taking measures that will prevent further spread of the virus. A highlight of this study is favorable attitude of the respondents towards stricter government measures against COVID-19 and their less favorable attitudes toward Philippine government response against the disease. A majority of the respondents feel that the government is not doing enough, specifically the Department of Health. Likewise, 7 out of 10 respondents were in favor of placing the NCR in ECQ, and the government should consider its policies in light of this result, including conducting massive testing of health workers, frontliners, and persons suspected of having COVID-19 in order to control the spread of COVID-19. So, by use of Kruskal Wallis, they conclude that the Department of Health is not doing enough to prevent the COVID-19, and they should lift the quarantine into stricter, like
Foreign literature, single value neotropic Kruskal Wallis and Mann-Whitney test. So this is our abstract. In this paper, Kruskal-Wallis test is extended to deal with neotropic data in single-value form using score, accuracy, and certainty functions to calculate ranks of SBNN. Also, Mann-Whitney test is extended to deal with same data type, which make it possible to do a post-hoc test. After rejecting null hypothesis using neotropic statistic Kruskal-Wallis test, numerical examples were successfully solved showing the power of this new idea to deal with SBNN and make statistical decisions on them. This is our formula on how to solve or compute the problem in our topic. C is the number of samples, and sub I is the number of observation in the I group. Summation symbol is the number of observation in all sample. R sub I is the sum of ranks of the I group. Notice that the H test tell us whether the samples are drawn from the same population or those samples are drawn from different populations. If we reject H, then we must determine the true differences location. We must do a post hoc test, and one of the famous used tests is Mann-Whitney test that tests the following hypothesis. Problem: we would like to compare judgment of 3 independent doctors on infecting with COVID-19 for 10 sick people. Each doctor is confident T% and unsure I% and may be giving wrong judgment F%. First, we calculate scores, accuracy, and certainty of the previous data as follows. Then, we rank our neotropic numbers based on its score, accuracy, and certainty as follows. Now, we rearrange samples and calculate sum of each sample neotropic ranks, and we get it. H sub n is equals to 12 over 30 times 30 plus 1 times 170 to the second power plus 130 to the second power plus 165 to the second power over 10 minus 3 times 30 plus 1 is equals to 1.2258. Comparing with critical value, say at 0.05 significance level, we find that H sub n is equals to 1.2258 is less than x to the second power times 2 is equals to 5.9915. So we accept that the null hypothesis and we say that all judgments are consistent. Conclusion. In this paper, they have solved the problem of making statistical tests on single-value neotropic number-based problems, which wasn't solved before. An algorithm of perform Kruskal-Wallis test and Mann-Whitney test when dealing with SVNN is presented and numerical examples were solved successfully in two fields of real-life problems, medical field and educational field. In future, we are looking forward to extend other statistical tests which are important in decision-making problems.
Here are the references that we used, and that's all for our group presentation. We hope that you understand well, and if you have any questions, don't hesitate to ask. Thank you.